Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Okay, we are looking at these charges, and it says three charges, A, B, and C, are arranged as shown below. So the question comes, it says, calculate the resultant force on C. So how do you go about this? Okay, this is what you have to know in simple terms. That this is the charge whose resultant force we are calculating. And you have to know that A has influence on C and B has influence on C. So when you add those two influences, what you get is going to be the resultant force. Okay? So what do we do? Let's start by saying the force A exerts on C. Okay? So within that force, what do we have? Let us look at A. We have QA. And what is QA? It is plus 2 microcoulomb, which is the same as 2 times 10 power minus 6 coulomb. It's a plus. Okay, it's between A and C. So what is QC? We know our C as plus 5 microcoulomb, which is the same as plus 5 times 10 power minus 6 coulomb. What else do we know? We know the intermediate distance. The distance is between A and C, which is going to be 2 plus 5, giving you 7 centimeters. And when you change this one to meters, what do you get? It's going to be 7 over 100, giving you 0.07 meters. Okay, what else do we know? Our usual K, which is that. Okay, with this information, what do we do? You have the formula. It's Coulomb's law, which is going to be that. And when you substitute in, what are we going to get? You have your K. K is 9 times 10 power 9. And Q1 is 2 times 10 power minus 6. And Q2 is going to be 5 times 10 power minus 6. Okay. The intermediate distance is going to be 0.07 squared. What do we get out of this? Let us see. So there we are. Our force is 18.367 newtons. Okay. So now the next part is going to be to determine direction. We have to know that this charge is positive and this one is positive. And we are calculating net force on C, so it's our C which will move when A is stationary. And where will C move? We have to remember that these are like charges. And what happens between like charges? They repel. So when repulsion occurs, where will C go? it will go to the right. So it's positive. On that account that we chose right to be our positive and left to be our negative. So after that, what happens? Then we go to the next one. What is the next one? The force B exerts on C. Or we can say the force on C due to B. And what do we get out of that one? Let us check and see. We know our QB. And our QB, it is minus 3 microcoulomb. If you do the conversion, what do you get? It's going to be minus 3 times 10 power minus 6 coulomb. Okay, then charge C. And our C is plus 5 microcoulomb, which is what? Plus 5 times 10 power minus 6 coulomb. Okay, then you come to R. What is our intermediate distance here? It is 5. It's centimeters. And what do? You convert it to meters by dividing with 100. What do we get? You get 0.05 meters. What's missing? Our K. So we have all the data to calculate that force. And the equation is going to be F is going to be equal to KQ1, Q2 over R squared. When you substitute, what do we get? 9 times 10 power 9. And the QB is 3 times 10 power minus 6. And QC is 5 times 10 power minus 6 divided by our intermediate distance, which is 0.05, but squared. Okay, what do we get out of this? Let us check and see. So there we are. It is 54 newtons. Okay. Then what is the next part? Find out whether it's positive or negative. We have to remember that it is the charge whose net you are calculating which is going to move. The other one is stationary. So where will C go? We have to remember that B is negative and C is positive. They are unlike. And the question is, what happens between unlike charges? They attract. So attraction will make C move to B, and that movement is negative. So what we have here is negative 54. So next part, what do we do? You have to quote our formula for Fnet. Fnet is the algebraic sum of the forces. So it's going to be F1 plus F2. Okay. So what is our F1? Our F1 is plus 18.376. It's very important that you know that this formula comes with its sign. So plus what? Plus negative 54 newtons. What you get out of here is going to be our net force. So that's it. That's what we get. It's negative 35.633 newtons. And what does negative imply? So this is what we will have to know, that our F net is going to be equal to 35.633 newtons to the what? To the left, because we took left to be negative. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. I'll not forget to remind you to subscribe, to like, to comment, to share. Yes, make this channel popular. We are simply the best. Bye-bye.